Okay, so let's go ahead and pick up where we left off. We just graphed secant and cosecant. So let's go ahead and work with doing some various different changes to the graph as we previously would have. So let's go ahead and recall. When we had our functions, we had a, and then we could have done cosine or sine, whatever it would have been, b, why did I write k? B, x plus h plus k. So if this is what we had right here, we have to remember that this a was our amplitude. If it was negative, it also reflected us across the x-axis. So in this particular case, a is exactly the same. 4 is going to be my amplitude. If it was negative, it would reflect me across the x-axis. B, I would do 2 pi divided by that number, and that gets me my period. That gets me whatever my horizontal stretch or compression would be. So whether or not my graph has been shifted from being like this to now being much shorter or even much longer. That's what that B value would do. And then the H value right here is whether or not my graph has just been shifted left or right, some value either way. And then this K value right here would just be shifting me up or down, okay? So given that, this 2 would be a shift up 2, and this 4 would be a vertical stretch of 2. It has not flipped my graph at all, but it has changed my Y values. Also, let's remember the B and the H values change your X values. The A and K values are going to change your Y values. So this is on the outside as well as this. So that's going to be affecting exclusively my Y values. So let's go ahead and write our original table that we're going to use. So gone ahead and made a table here, and I labeled it with the original x values that we would use for our function from 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, let's consider. I have what function here? I have secants. So that means what I'm going to be working with is cosine. So that's going to be the graph that I'm going to flip. I'm going to go ahead and I'm going to treat this entire table, I'm going to treat this as if I'm looking at the equation of 4 cosine x plus 2. That's what I'm going to do. And I'm going to do this because once I've got this, all I need to do is just flip it, and I've got the rest of my graph. Okay? So if I do 4 cosine x plus 2, then cosine, my y values would go here, and I'm going to go ahead and put 1, 0, negative 1, 0, 1 for cosine, right? And now if I go ahead and apply these transformations, that 4 would be, I'm going to multiply that to my y value because it's going to make it be taller. So I have 4 times y, and then I'm also going to shift up 2. So I have plus 2. So I'm going to take all of that information, I'm going to apply that to the y. So I have 4 times 1 plus 2. Well, that's going to get me 6. Then I have 4 times 0 plus 2, so that's 2. 4 times negative 1 is negative 4. Negative 4 plus 2 is negative 2. And then 4 times 0 plus 2 is back to 2. And again, 4 times 1 plus 2 is also 6. So what I've done is I've taken the 4 out front and I've vertically stretched my graph by a factor of 4. I've taken the 2 that's added at the end and I've shifted my graph up 2. And then I can go ahead and graph that function right now. And so what I would do is I have this entire XY axis that's right here. And so I have not changed those X values. So I'm going to go ahead and I'm just going to label those just like I have been. And so this would be pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to label my y-axis. Well, if you notice, my lowest one is going to be negative 2. My highest one is going to be 6. So I'm going to go ahead and go, okay, so I got negative 1, negative 2. And then I'm going to go 1, 2, 3, 4, 5, 6. Okay. And I'm going to go ahead and I'm going to label my midline, which is that 2. So I'm going to go ahead, just do this, make it a little bit easier for myself while sketching. And I'm going to go ahead and draw the ghost graph, meaning I'm going to do the little dashed lines that I would do. So at 0, 6, so I have a coordinate point here at 0, 6, one here at pi over 2 and 2, one here at pi and negative 2, one at 3 pi over 2 and 2, and one at 2 pi and back up at 6. And so I've got this little dashed line thing that I'm going to do here. Okay, so that is my ghost graph of cosine, and now I'm going to invert it. So everywhere where this graph touches this midline, so this midline that I drew right here, so that midline, everywhere where the graph touches that, I have a vertical asymptote. Okay, so I'm going to draw those vertical asymptotes right there. And again, everywhere that the graph itself was opening down, I'm now going to change and open up. So right here, it's now opening up over here. And everywhere that it was opening up, now opens down. And it would be opening up over here as well. So that's going to be the graph that I would have for secant x plus 2. The red is for cosine x plus 2, but the blue is for secant x plus 2. So what is my domain of this function? Well, it's going to be negative infinity to infinity. But what can x not equal? X cannot equal, I cannot equal pi over 2. And then if I go ahead and figure out what's the difference here, that's going to be pi over 2 plus pi, k, where k is an integer. All right, so then what's my range on this function going to be? Well, just like cosecant, it's just going to go ahead and it's going to be from negative infinity. And then in this particular case, it's not going to be from negative infinity to negative 1 and 1 to infinity. If you notice right here, the lowest I'm going is negative 2. So it's going to be negative infinity to negative 2. I should say the lowest I'm going on my y-axis. Union. And then the highest point I had on my axis for cosine was 6. So it's going to be from 6 to infinity. Okay. My period of this function, again, 2 pi over b. Well, here b is 1, so it's just 2 pi over 1, so that still gets me 2 pi. My asymptotes, again, pi, oh, I gotta do x equals. It's going to be x equals pi over 2 plus pi k, where k is an integer. Okay, so I will go ahead and say the restrictions here on the domain and the asymptotes, that's going to be the thing that's going to be a bit more challenging for people, and hopefully it makes a little bit more sense after this next example, because this next example is going to address a phase shift. Or I shouldn't say phase shift, a period change. Okay, so if I go ahead and consider all the things that I've got on this, again, I'm going to treat this as if it's negative sine 2x plus 5. So let's consider what this is doing. So this 2 right here, this 2, that is a period change. That is a b value. That's within the trig function, and it's being multiplied. This negative out front is my a value. So it means that I have a negative 1 for my a. So I have an amplitude of 1, but I have a reflection across my x-axis. And then this plus 5 is on the outside of the trig function. So it's afterwards. It's on the outside. So that's going to be a vertical shift of 5. So let's go ahead and see what that does. Let's go ahead and create our table of values and go from there. Graphing sine. At 0, sine is also 0. Pi over 2, it goes up to 1. Pi back to 0, 3 pi over 2, negative 1, and 2 pi is back to 0. So this would be my actual table that I would have for if it was just sine x. And I would graph just like that. But it's not just sine x, it's negative sine 2x plus 5. And then I got to turn that sine into cosecant. So what I'm going to go ahead and do here is I'm going to address my x values first. So my x values are going to be changed. How? Well, this negative out front is going to my y value. This 2 right here is on the inside. That's going to my x value. And this 5 right here is on the outside, so that's going to my y value. So the only thing that's going to my x values is that 2. Remember, if something's on the inside, you're doing the opposite. So since this says sine 2x, it's going to be it's 1/2. So I'm going to go 1/2 of whatever my x values are. So half of 0, well, that's still 0. Half of pi over 2 is going to be pi over 4. Half of pi is pi over 2. Half of 3 pi over 2. Well, you might not be able to do that in your head, Hopefully you can, but if not, that's okay. What am I doing? Divided by 2, so then I keep change flip. So then that gets me 3 pi over 4. And then if I did half of 2 pi, that's pi. If you notice, I go 0, 1/4, 2/4, 3/4, 4/4. Okay? Just kind of pay attention to that. It makes it kind of easy if you can figure out the distance from the first one to the next one and kind of count from there. All right. Now, what I've got right here, I've got this negative here, and I've got this 5 here. Those things are going to be addressing my y value, so I'm going to go negative y plus 5. Remember, they are on the outside. So since they're on the outside, I'm not doing anything where I'm changing it to be the opposite of what you see or anything like that. I'm not turning this into a negative 5. I'm not turning this into a positive. I'm not doing any of that. If it's on the inside, I do that. If it's on the outside, it's just whatever you see. So I'm going to take all of these y values, I'm going to multiply them by a -1 and add 5. So if I go ahead and do that, that's going to get me 5 here, 4 here, back to 5. Then I would be at 6, and then back to 5. So that's what I would have for all of those values. So I can go ahead and graph this. So I'm going to go, all right, so here's 0, 1, 2, 3, 4, 5, 6. So basically, my whole graph is going to exist right here on this y-axis between this 4, 5, and 6. I'm going to go ahead and I'm going to draw my midline, which is going to be just this little dashed line that I'm doing right here, straight through 5. And then I'm going to go ahead and just start going from there. So if this is sine, and I was graphing this, I go 0, 5. So here I'm at 0, 5. Then my next point at pi over 4, 4. Oh, I didn't label my x-axis. I probably should do that. So I got pi over 4, pi over 2, 3 pi over 4, and pi. All right. I have this right here, and I would go ahead and I go 0, 5, pi over 4. I'm going to go to 4, pi over 2, back to midline, 3 pi over 4, up to 6, and pi, I'm at 4. So again, this is a ghost graph, so I'm just drawing dashed little lines right here. And now I've got my little reciprocal of sine, and I'm going to go ahead and draw my vertical asymptotes everywhere that I'm crossing that midline. And that's going to be, again, at 0, pi over 2, and pi. All right, and then again, everywhere where the graph is opening up, I'm going to flip it, and it's going to open down for the actual graph of cosecant. So I'm going to be opening down over here, and I'm going to be opening up over here. And then I'll go ahead and I'll finish up the rest of this problem in the next video.